Hi, this is the Nylon 12 SLS material testing group, which is Ford number 2. So our group is working with Ford's Additive Manufacturing Center located in Renford, Michigan. Our Ford contact, Dan, came to us because their current method of testing 3D printed parts was very inefficient and was creating unreliable data. So he wanted us to find a solution to this problem. Ford mainly uses SLS 3D printers to create their parts. This type of printer is categorized as a powder bed fusion type. It uses laser to fuse together plastic powder layer by layer in order to create the desired geometry. The material that Ford uses and that our group is working with is nylon 12 powder. Since this is a very fine powder, it poses many challenges when trying to test. Ford previously had 2 test methods that they were using to determine if their 3D printed parts were suitable for use. One of the tests was a tensile test. This machine pulls the specimen to its breaking point in order to gather information on stress, strain, modulus of elasticity, and ultimate tensile strength. This was not a main area of concern for us because a tensile test creates very accurate data that can be replicated easily. Additionally, tensile testing does not take long to complete. The other quality test that Ford was using was a melt flow test. For this test, powder material is inserted into the top of the barrel of the machine, heated into a viscous fluid, then pushed out with a piston. This process has much more room for error than the tensile test, and our Ford contact mentioned that oftentimes the data collected is not used because he cannot be certain that it is accurate. Additionally, the melt flow test machine is very time consuming. It takes Ford team members up to an hour to complete. That's 15 minutes to test and 45 minutes to clean. Therefore, Ford came to us to find a new solution to their issue, and this test method can ensure consistent results when determining if the nylon 12 material is suitable for use.
Hi guys, my name is Hayyan, and I'll be going over some of the things that we researched into, kind of what route we're taking with this project and what we plan on doing. So first thing first, like we mentioned, Ford already has implemented 2 tests that they're doing, the tensile test and the melt flow test. And what we've seen from the tensile test is that it's a really reliable and consistent test. It provides efficient data consistently for us, and there's nothing wrong with it, so there's no need to replace it. The tensile test is a great test in telling us what the strength of the material is, the dog bones, and to see, the quality of the powder in one way. The other test that Ford had was a melt flow test. And that's a test that our Ford contact kind of was looking into replacing, seeing what some of the problems were with that it was taking too long, wasn't producing reliable, consistent data. And so that's essentially where we focused in onto. And through our research, we saw that there was this particular student, Lucas Duddleson, at the University of Wisconsin-Madison, who did do some research in this field. He's a graduate student there within their polymers department, and essentially what he did was compared 3 different ways of testing polymers, 3 different ways of testing nylon 12 powder, and seeing which one is the best one, which one is most repeatable. So which is very similar to our test because that's kind of what we're looking for. And through his research, he concluded that the DSC, the differential scanning calorimeter, was more effective, was better, was most accurate in determining the quality of the powder compared to the TGA or the melt flow index. And so with that knowledge that we had, we decided, okay, let's go forward with the DSC. And let's give Ford, before we tell them to replace the melt flow test with the DSC, let's conduct some DSC testing on our campus because we already have that machine on our campus. So we have that machine, we'll get some powder from Ford, we'll run some tests on campus, we'll prove to Ford that this test is much more efficient. Like the melt flow index, it doesn't take 45 minutes to test and clean the machine. It's very clean, repeatable, and we'll present that to Ford once we can conduct that testing at CMU. So going a little bit more into the DSC, essentially what it is, it just measures the energy that's required to heat a sample at a constant temperature. And how it does this is, as you can see on the right side, we have a reference pan and a sample pan. So the sample pan has our powder, and the reference pan is going to be empty. And so essentially when it goes through the heat cycles and the temperature ramps, it will measure with the difference. And with that difference that we get at the end, the energy difference that we have, with that we're able to determine the enthalpy of melting, enthalpy of fusion, crystallization, melting temperature point, fast transition temperature point, and a few other things. So that's essentially the data that we're looking for. And with that data that we have, and we'll go into this a little bit more in detail in the upcoming slides, but with that data, we're able to determine the quality of the powder. So that's everything that we need, to determine for Ford if the nylon 12 powder that's being recycled, the 50/50 powder, is some of it thermally damaged. And if it is damaged, is it damaged enough to the point where we can't use the powder again? Or is the quality of the powder still good? And like I said, with the melting temperature point, we'll be able to figure that out. So we located the DSC on our campus. We talked to the professor. We talked to the grad students that were, doing their research under that. And we were able to receive a demo on this test. I actually did some research with this professor during my undergrad time. I was familiar with the instruments a little bit, but our whole group, got a demonstration on this test. We were able to see how the test is conducted, how the software is used, and how we're able to locate that melting temperature point that we needed. We explained all of this to Ford. They were looking forward to it. They were looking forward to the results. And so all we needed was some powder from Ford and some dog bones for our test. So what we did was submitted this bill of materials that you can see on the right side on the bottom. And you can see that we had 3 different batches where we had 100 grams of powder for each batch. And we had 50/50 for 2 batches or 3 batches. And then we had another 4th batch where we were testing recycled powder. And then we were also testing completely virgin powder. So we have completely virgin and completely recycled powder, which would set the threshold for us. While the 50/50 powder, that's kind of to see, if the 50/50 powder is, good quality or not.
Hi, I'm Doug, and I'm going over our meeting with TA Instruments. So as previously mentioned, we determined that DSC would be the best route for testing our nylon 12 powder. We learned that the engineering building has a DSC machine, which is currently maintained by Dr. Shin. It's a DSC 25 machine, and it's manufactured by TA Instruments. Since eventually we're going to be recommending this machine to Ford for purchasing, we looked up pricing for it. There was nothing available online, so we reached out to TA Instruments directly and set up a meeting. We met with 1 sales representative and 2 laboratory specialists who worked with the machine regularly. They asked how we discovered DSC and what our goals were for our testing. We explained our research and how we came to the conclusion that DSC would be a viable solution for testing our nylon 12. After hearing this, they confirmed that DSC testing could do exactly that and give us that melting point that we were looking for. After they confirmed that DSC testing would work, they explained the different options that they had available. Since Ford only needs the DSC machine for a relatively narrow scope of work, they recommended to stick with the DSC 25. They do offer the DSC 250 and 2500. Both of these offer increased accuracy and precision. Additionally, they offer special features like the T0 heat flow and advanced heat flow and then direct CP measurement. However, they explained that there would be no added benefit for Ford since these are features that they would not necessarily be taking advantage of, and explained that the DSC would be the best machine for Ford to use.
Throughout the semester, we have come to terms with the fact that running our tests on the nylon 12 powder is not as simple as a task as we originally thought. We have run into a few obstacles along the way, which have taught us how engineering projects will actually go in our careers. Our first obstacle was the tensile test. We originally planned on testing dog bones in the Instron testing machine at CMU. We realized that since Ford's tensile testing methods do not need to be improved or upgraded, spending our time on tensile testing is not as much of a priority as the DSC tests. We then shifted our focus to the DSC testing. The nylon 12 powder is located at the Ford Advanced Manufacturing Facility in Redford, Michigan, which is about a 2-hour drive from CMU. Our Ford contact has been very busy at work and has faced a few obstacles of his own. The 3D printing machine he uses with the nylon 12 powder ended up breaking down, so we were not able to obtain both the virgin and the thermally degraded powder at this time. We were able to meet up with our Ford contact, and he gave us 100 grams of virgin powder to test with first. Testing our powder has also been a lot more difficult than we originally thought. Our original plan was to use Dr. Shin's DSC machine on CMU's campus. We received a demo from Dr. Shin's graduate student in order to get more acquainted with the DSC machine, and we would be able to run the tests on our own. After our demo, we were told that the machine had been contaminated by another user and it would give us unreliable data above 100 degrees Celsius. Since our melting point of our powder is above 100 degrees Celsius, we needed to look elsewhere to run our DSC tests. Our plan B was to contact Dr. Hasili, who is also a professor in the engineering department at CMU. He first wanted us to make sure that the nylon 12 powder would be okay to use in his DSC machine. So we contacted the vendor of his DSC machine, and they gave us the go-ahead to use the Net Instruments machine. So after working through those details, we ended up setting up a time to test with Dr. Hasili. However, the hydrogen tank that is connected to his DSC machine was empty, so we needed to move on to plan C and look elsewhere because ordering another hydrogen tank would take too much time and we are nearing the end of the semester. So we ended up contacting Dr. Lee in the chemistry department, and she is willing to help us run our tests as early as this coming Monday, the 15th of March. So that will be our current plan that we're working through in the chemistry department. And if needed, Dr. Hasili did let us know that there are some labs in the community within the Midland, Mount Pleasant, and Clare areas that we might be able to move forward and test our powder in the community if needed, if we need to move on to a plan D. So since I have explained the obstacles our team has faced over the semester, I will pass it over to Peter to explain our next steps that we will take moving forward.
After overcoming all the complications with being able to actually run the DSC tests, we resorted to our last resort, which was reaching out to the chemistry department. We have our contact, Dr. Lee, there, who was able to inform us that her grad student, Jacob Lentz, would be able to run the test for us. So on Monday, the 15th, at 10:30 a.m., we will be receiving our second batch of nylon 12 powder. The first batch is just virgin powder, and the second batch is powder that has 10 hours of runtime on it. So we'll be able to drop these samples off that week, that Monday, the 15th, and we'll give the chemistry department till the 19th to run the test. So right now we are working on having Jacob record his testing either through WebEx or by his phone. And this would help us get a better idea of how the procedure works. So ultimately we want to prove our previous hypothesis. The test is quick and efficient. Having Jacob run the test and record it for us, we'd be able to prove that the test is quick, and we're pretty certain that it's going to be efficient. We have much research to back up that it's an efficient test, but our contact Ford wants a quicker test, so we want to be able to prove this to Ford. And the goal of this too would be able to have a written procedure so that Ford could implement this at their AMC facility. So our expected results. From Lucas Duddleston's thesis paper, we have these images over on the right. As you can see, the bottom right photo, you have the virgin powder, which is a lightened line, and you have the tested powder, which would be our powder would be 10 hours runtime, is darkened. So with this graph, you see heat flow is on the y-axis and temperature is on the x-axis. Specifically looking at temperature, you can see that the virgin powder is going to have a higher melting point, and also it's going to have a higher melt flow index. Also, looking at the graph, this area under the curve right here is our enthalpy of melting. As you can see with the virgin powder, we're expected to have a higher enthalpy of melting. has not been thermally degraded yet, so its structure is stronger and in contact more. So with these results, we conclude that the DSC will identify thermally degraded powder. The DSC accurately shows the melting point, which is important because this proves that we can replace the melt flow machine. The challenge of this test is determining a threshold. Since we don't have adequate time and resources to run a DSC, melt flow, and tensile of the same batch of powder, we're going to have to base our threshold off of research. This will be the bulk of our project and the ultimate goal.
So wrapping up, we believe that DSC testing will be the best fit for Ford's material quality tests, and it will impact their material testing process in a variety of ways. And some of these benefits include significantly reducing the testing time. As stated previously, the melt flow machine took 45 minutes to completely run a test that included cleaning the machine. And the DSC will need minimal cleaning as opposed to melt flow machines, so Ford will be able to run multiple tests in very quick succession as opposed to very few tests with the melt flow machine. In addition, the DSC will produce very reliable data that will show if nylon 12 is thermally degraded and is much more reliable than the melt flow machine used previously. Along with that, a standardized and simpler testing procedure will contribute to producing more reliable data using the DSC, and it will be easy to use for the operators of the testing apparatus to conduct tests. Also, the results that Ford will be keeping from DSC testing will contain melting point and enthalpy of melting from the DSC charts that will be obtained through testing. A threshold for to discarded thermally degraded material will be obtained from research, and thermally damaged material that will be below this threshold will be discarded and not used for future nylon 12 builds. The thermally damaged batch that is above this threshold will be mixed with virgin powder and used in future nylon 12 builds. And overall, Ford will be, when they implement DSC testing, they'll be able to determine which materials that are thermally degraded and if the powder will be able to be mixed 50-50 with virgin powder, and will get reliable material quality data so they can produce quality parts for their nylon 12 builds.